Here's a question. You have a list of numbers and a target. Can you find every group of 4 that adds to it? And every quadruplet has to be unique. No repeats, even if the numbers come from different spots. Take this list. The target is 0. 3 different quadruplets work, and we want all of them. Highlight the answers. -2, -1, 1, 2, -2, 0, 0, 2, -1, 0, 0, 1. Notice the second answer uses both zeros. Same value, different positions. That's allowed. Same indices twice is not. Okay, try the obvious thing. 4 nested loops. Pick 4 numbers, check if they add to 0, write them down. But there's a problem. -2, 0, 2, 0 adds to 0. So does -2, 2, 0, 0. Same set, different order. So we'd need a separate set just to dedupe, and the loops grow with the input to the 4th power. On 200 numbers, that's over 1 billion combinations. We need a smarter shape. Pause here. Look at the list again. The numbers are in random order. Does that ordering help us at all? Not really. But what if we sorted it first? Now duplicates sit next to each other, and small numbers come before big ones. Now think back to 3-sum. We sorted fixed one number, then swept 2 pointers from both ends. 4-sum is the same shape with one more pointer fixed. Fix 2 numbers up front, then sweep the remaining 2. And the sort gives us dead up for free. If the next number is the same as the one we just used, skip it. Watch out. You might think you skip if the current equals the next. Don't. Skip if the current equals the previous. Otherwise you never use a value at all. Let's walk it. Sorted list, target 0. Outer pointer A starts at -2. Inner pointer B starts right after A, at -1. So we need the last 2 to add to 3. Now the 2 pointers, L sits next to B at 0. R sits at the end at 2. Sum is 2. We need 3. Bump L right. L is on 0 again. Sum is still 2. Push L right once more. Now as 1 R is 2. Sum is 3. Match. Record -2, -1, 1, 2. Now move both pointers inward and keep searching for more matches with the same and B. O crosses R. Done with this B, bump B to 0. Now need is 2. L starts at the next 0, R at 2. Sum is 2. Match. Record -2, 0, 0, 2. Now B would step to the second 0. But we already used 0 as B, skip it. And that's the whole loop. Outer advances, B sweeps after it, 2 pointers close in. Same dance, 1 layer deeper. Notice what just happened. We never built a dedupe set. The sort plus the skip rule kept every quadruplet unique on its own. 2 fixed pointers cost us a square, and the inner sweep is linear, so the time grows with the cube of the input. Let's write it. Sort first, then loop the outer pointer. Skip it whenever it repeats the previous value. Same idea for the inner pointer, but compare against a +1 so the first B is always allowed. Now the 2 pointers sweep. Compute what we need, then close in based on whether the sum is too small or too big. On a hit, record it, step both pointers, and slide past any repeated values so we don't log the same quadruplet twice. And that's the pattern. Sort fix 1, fix another, sweep 2. Every case sum problem is just this idea, 1 layer deeper.